Hello friends, in today's question, mass m is suspended as shown in the figure. The system is in equilibrium. Assume pulleys to be massless. K is the force constant of the spring. So we have to find out three things. First is the extension produced in the spring is. Second, the net tension force acting on the lower support. And third is if each of the pulleys A and B has mass m, then find the net tension force acting on the lower support. Assume pulley to be frictionless. So this is the figure. We have two pulleys A and B. With A mass capital M is connected, and they are, with the help of pulleys, they are connected with the lower support. And there is a spring whose constant is K. Spring constant is K. So let us draw the free body diagram of various forces which are acting on these. So let us suppose the downward direction here, that will be mg, and here will be tension T, and this is same string, so this will be T also, and because of this will be 2T, and similarly this will be also a 2T. Okay. So these are various forces which will be acting on it, and this is for the when the pulleys are considered massless for A and B. Okay. When the pulleys, they will mass, it will be a little bit different with respect to the mass of A and B. So we can say that it is given that system is in equilibrium. So we can say as system is in equilibrium for mass m, you can say tension T is equal to mg, and we also assume that the spring moves in the downward direction with the distance x. You can say for if x is the extension produced in the spring, if the extension produced in the spring, we can have that the total force which will be balanced by spring will be 2 plus 2, that is 4T. So then we can say Kx is equal to 2T plus 2T, which is equal to 4T. We already know value of T, that is mg, so this will be 4mg. From here we can find out that the extension x will be equal to 4mg divided by k. So this is the extension of the spring. This is the extension produced in the spring. And for B part, net tension of the force acting on the lower support. So this is a lower support. Here we have net tension will be equal, there are two, let me draw it here. So this is lower support, we have two strings, and the tension will be 2T here, and there is 2T, so net will be 3T. So this is our lower support. So net tension on the lower support will be equal to 2T plus T, so which is equal to 3T. Substitute value of T, we get net tension will be equal to 3 and this mg. So this is a net tension on the lower support. This is the net tension on the lower support. In the C, now there is a mass given of A and B as capital M. So let's draw the free body diagram for specifically for A and B. So this will be our pulley A and pulley B. This is connected to pulley A and pulley A is connected to a mass of capital M, and they are both connected to this lower support. P. So now here will be mg, okay, and let us suppose here is tension T, here will be also T, and here we say, let us say it is T1, so here also it is T1. In the downward direction we are going to have mg for the pulley A, and for the pulley B also there will be mg. So let's find out what will be the relationship between T1 and the rest of the, you can say, forces which will be acting respectively for pulley A. So we can say for pulley A, T1 will be equal to T plus mg plus T, because there are two downward forces and T1 is acting upward. So this will be equal to 2T plus mg. Value of T we already know is capital Mg, so we can say T1 will equal to 2 multiplied by mg plus mg. So this gives us the tension T1 will be equal to 31 mg. Okay. So once again we are going to find out what will be the net tension on the lower support. So this is a lower support. So net tension on the lower support will be net tension is equal to T1 plus T. And T1 is 3 mg and our T is mg. So we can say net tension will be equal to 4 mg. So this is net tension when the mass of A and B is M. So this is the net tension when mass of pulleys A and B is capital M. So this completes the question. Thank you.